led the nation. Led the nation in deep entire world, continuing its adventure of human space exploration, discovery, and achievement, playing a vital role of powering the United States in the 21st century through technological innovations and scientific discovery. Established in 1961 as the Manned Space Flight Center, and later renamed the Lyndon B. Johnson Space Center in 1973, in honor of late President and Texas native Lyndon B. Johnson, the JSC complex sits on 1,620 acres donated by Rice University and is a home to NASA administration, astronaut training, and mission control. I'd like to officially welcome to the Johnson Space Center. If you look to the left, this 16 acres is home to some of our famous Texas Longhorns. Woo! Hook 'em horns! Is there any Aggies on board? Well, why might you ask, does NASA have Longhorns? Well, contrary to popular belief, they're not teaching to jump over the moon. After all, that would be a load of bull and utterly ridiculous. I like this young up. Alright, ladies and gentlemen, take a look to the left. You'll see the mighty Saturn V rocket. This building was constructed in 2011. Texas heat and humidity can be quite harsh on anything that sits outside the Smithsonian. Collected enough money to build this structure around the Saturn V. This is one of only 3 Saturn V's left in the world. This one is flight ready. NASA wanted to take it, assemble it, refurbish it, fuel it, and would fly in space. 363 feet. Its length is longer than a football field, taller than a Statue of Liberty, weighing in at 6.5 million pounds, and developing 7.5 million pounds of thrust. All of that proceeded to get 3 astronauts and 4 pieces of hardware to the moon and return it safe to Earth. Also, if you take a look to the right of the load of rocket parts, two rockets we have out there. The one on the right is a Mercury Redstone, which was developed as a ballistic missile by the United States Army. Only having a range of about 100 miles, it took our first astronaut, Alan Shepard, on a suborbital 15-minute flight. Small steps by today's standards, but nonetheless, it was America's first steps into the space race. To the left of that, you'll see the Little Joe 2. Now, the Little Joe 2 was used as a test booster for the launch escape system. And that's that rocket that sits on top of the Apollo crew capsule. Now, what would happen is that they would launch that up to an altitude of about 14,000 up to 75,000. When they would fire that rocket, they would pull the Apollo crew compartment away from the booster and then an emergency. It kind of works like an ejection seat on a fighter aircraft. But this would pull the entire crew compartment away. I don't think you want to eject in Mach 10 plus. So they would stay safe inside the crew compartment. The launch escape system would pull it away in the event of an emergency. JSC was donated by Rice University. Actually, was sold by Rice to NASA for $20. That's quite a bargain. It's 1,620 acres. With one stipulation, that if NASA ever failed, Rice University would have an additional campus. So, as you can see, we're still going strong. So, I guess they lost. scientists and engineers are working on evaluating the right spacecraft and it's also held in a food preparation lab. That's where the astronauts have their meals prepared. Now, there is no refrigeration on board the International Space Station. Everything has to be dehydrated and back to pack. And what they'll do is they'll rehydrate it with hot water on board the island and enjoy a nice cold cooking. And if you look to the left, you'll see Building 21. Building 21 is a human health sciences center. That's where the astronauts get their physicals. And it's also home to the twin study. Now, if you know, we have two astronauts in the twins, Mark and Scott Kelly. Scott spent a year on the International Space Station, and when he was there, he compared notes to see if there was any difference. We find out that the regular flight basis were and if you see some of the video of the astronauts, when they first arrive on board, the things that look kind of frustrating because a lot of the and after a while, they have to time for that. If you look to the far left, you'll see a building that has a couple of radar guns on top of it. That's the Anticoast building. You can walk in there and talk, and the walls will absolutely have absorb all of the sounds, and there's no echo in there whatsoever. And they can test some electronic equipment in there as well. And ladies and gentlemen, if you look forward, like to the right, you'll see this large raised building. That is the Space Environment Lab. Now, that's over in Boulder. It's a large door. And what they'll do is they'll close that large door, they'll lock it, they'll withdraw all the air to keep things fast. Then, they'll come in liquid nitrogen. It's up here in these white tanks. This liquid nitrogen is kept at above chilling negative 320 degrees. They'll come down in there, they can simulate a hard-cold environment, vacuum space. And the opposite way, when it heats things up, they'll put items inside the vacuum chamber to the right, so it's like the sun. Just a little bit of advice from a native citizen who grew up here on the Gulf Coast. It's quite even today, so please stay well hydrated while you're outside. And as we come up to the street here, prepare to leave the right, I'd like to call your attention to the right. Find the racing lab. Now, there's a lot of stresses on equipment. It's on. A lot of stress, like radio sound, heat. So they'll take the equipment in there and they'll shake it, try to recreate the acoustic vibrations of the old up. And as you can see that row of trees way out there, well, you know, they don't want out there. There is a running track out there, so the astronauts can go out and get some cardio, try to stay safe. I don't know about doing that this humidity. You can see 4 deer over here to the left. Under the trees, you see the big ears sticking out. And if you take a look to the left, you'll see Building 220. That is home of the Hera project. Now, what they'll do is they will do human psychological studies maintenance. Other thing you can think of is you have fire department, we have a small city also have here. If we turn right, I'm going to ask everybody to stay seated and hold on. This road is quite bumpy. We don't want to lose anybody. Okay, ladies and gentlemen, we're making our way along this road here. We're going to come up to the stop sign. We're going to take a left. We're going to remain seated until we get out here. The doors open for you. Now, there are 26 steps there. If you are section on the climb road, talk to our driver here. Elevator. Also, I'd like to ask everybody to maybe ask about the work that's going on in there. They take pictures of food companies of glass. Look to the left here, some of the same ones that were here since NASA's inception in 1961. And they were used by the workers and possibly even some of the astronauts to ride in between the buildings here when NASA was in its infancy. We do have a contract with JS, the twin lights, building out there anytime soon. Good one. Okay, we'll pull up here, I'll get out, and the doors open one side, everything in there, and let me have a look at the button on the classroom.
So the train.
Okay. Alright.
I'm not seeing the train.
He's one of these with a different training module.
Okay, ladies and gentlemen, you can please walk down here where I'm waving my hat. Need everybody to file in as quickly as possible, please. We do have another group coming up behind us. So please try to file down here safely and as quickly as you can.
Yeah.
No need to run, you can just walk briskly. I'm down here waving my hat, so needed to file in here as swiftly as you can. Continue to walk in towards me, please.
Turn around. There you go. Turn around. Mama, turn around. Yeah, that's a lot.
Each one of these is a different training station, Carter.
Ladies and gentlemen, just coming in, please walk this way, please, while I'm waving my hat. If you're just walking in the building, please continue to walk this way for me.
Guys, you know, the day goes
I think as long as you don't have flash.
Okay, ladies and gentlemen, welcome to the astronaut training facility. This is the astronauts' classroom. This is where they learn how to work and live in space. So if you want to draw your attention all the way down to the far right to the American flag over there, the far right end. Over there you will see two plaques. One is for Challenger and the other one is for Columbia. They're there to remind us of the sacrifices that were made. Also, if you look against the far wall, you'll see that black background. In front of it is a model, scale model of the International Space Station and the configuration that it is now, orbiting above us at 220 miles, traveling at a speed of 17,500 miles an hour. Down on the floor in front of that, you will see those are all the modules, the American modules that are on the International Space Station, and to the left are the Russian modules. Now, if you look where the Russian modules are, you'll see all those plaques on the side of the Russian module there, and those are all the expeditions that have been up to the International Space Station. Now, if you look down, you will see it looks like two green olives, one on top of the other. That is the old Soyuz Russian spacecraft. Now, at the end, for the period at the end of the shuttle, till we started launching here in 2020 with SpaceX, that was our ride into space at about $90 million a seat. Now, it was a round-trip ticket. Also, if you look down, you'll see to the right there, if you look down next to the Soyuz, you'll see the Boeing Starliner. That's one crew compartment is being evaluated for future missions to go to the moon and on to Mars. Now you'll see a mock-up of the, over here, you'll see a mock-up of the space shuttle. Okay, if you look to the right of that against the far wall, you'll see a large blue structure that looks like a giant swing set. Now if you look down, you'll see what looks like a stage. That's like a big air hockey table. Jets of air will come up from the floor and it'll create a frictionless environment so the astronauts can practice moving equipment around as they would in space. So they try to get as close to the environment of space as possible, simulate as many of the conditions as they can. Now if you look forward, it's to the left of the Soyuz. Okay, you'll see this large white cylindrical habitat. That is called Gateway. Now, Gateway will be in orbit around the moon, and it's kind of like a hotel. You know, when you get to your destination, you want to get off the plane, out of the car, get up to your hotel, stretch your legs, lay down, rest a while, you know, maybe take a shower, grab a meal. Well, it's going to work the same way. When the astronauts get to the moon, they'll dock with Gateway here. They'll be able to get out, rest, you know, maybe get a meal, check out all their equipment before they head down to the lunar surface. And to the left of Gateway, against the far wall, you'll see one of the two lunar vehicles that will go down to the lunar surface that are being evaluated. This one is Artemis, and it has the legs on it, kind of like the old lunar module that are wrapped in gold, and that's to protect all the propellants from that harsh direct sunlight.
It has a descent stage and an ascent stage. The descent stage will carry us down to the moon. That part will stay on the lunar surface and serve as a launch pad for the ascent stage when the astronauts are ready to come back up. So like the old, unlike the old lunar module, or unlike the old lunar module, instead of carrying 2, this will probably carry up to 4 astronauts. And to our young ladies here, one of the first astronauts to walk on the moon again in 2024 was going to be a girl. Okay, folks, if you'll follow me down to the end, we'll go all day and check out the second half here.
Are you going to do that one day?
This is your classroom.
So, ladies and gentlemen, I ask you to move down here, at least to the left of the gateway module. And you're welcome to move all the way down. You can move all the way down to the wall. Far wall, you can move all the way down if you like.
Yeah, I know.
Ma'am, you can move all the way down if you'd like. All right, ladies and gentlemen, if I could draw your attention to the far back wall, you'll see another large blue structure, kind of like a crane. That is called the 6 degrees of freedom. So in space, they still maneuver in 3 different axes, as an aircraft would here. On Earth, the nose goes up and down on an aircraft. That's called pitch. If it goes left to right, that's called yaw. And when the wings roll, of course, that's called roll. So they can simulate those 6 degrees of motion in space. So what they'll do is they'll attach a mock-up of a space vehicle or the seat with a hand controller, and whoever's training there can simulate moving in those 6 degrees of motion. And that's used to practice for docking maneuvers, rendezvous, whatever they're going to need to do to maneuver their spacecraft wherever they need to. Now, in the old days of Apollo, all that was done by hand. Today, it's done by computer, but those 6 degrees of motion are still used in space as they are here on Earth. Now, if you look to the right of that, you'll see the Orion capsule. Now, it's one of the vehicles that's being evaluated for our return back to the moon as well as Mars. That one is a little bit bigger. It's the same configuration as the Apollo. It's the Hershey's Kiss, as I like to call it. But it's a little bit bigger. This one will accommodate 6 astronauts, whereas the old Apollo could only accommodate 3. Now, if you look over if you can see where I'm waving my hat here, okay? This is where you'll be able to see it. You people on the end may not be able to see it too well till you get down here. If you look down, you'll see one of 2 robots. Okay, those are the Valkyrie robots, and they're being evaluated to do everything from repairs to maintenance to perhaps even one day rescuing an incapacitated astronaut outside the International Space Station. So, humans are probably the weakest link in the space exploration. We require oxygen, we require heat, we require protection from space. These robonauts will just be able to go out. They don't have to suit up or get any air. They can just send them outside as soon as they get them in the airlock. Now, right now, they can't stand up on their own weight, so they're working on that to get them to get their balance. It is quite a bit of robotic programming and engineering. The technicians here will wear VR goggles, and they'll also wear some telemetry gloves So whatever they do is instantly mimicked by the Robonauts down there. And when you head this way, if you look to the left, you'll see another one that's actually called Robonaut, and he's kind of like R2-D2. They have legs on him right now, but it's designed to function without legs, so it can grasp onto any part of the outside of the spacecraft, as well as the International Space Station, and go ahead and do any work that they need done. Now over here to the far left, against this far left door, you'll see another blue structure, and it's called Argos. Now that's used to simulate low gravity. As the astronauts would encounter, they'll put on a spacesuit, which is quite heavy, some weigh anywhere from 200 to 300 pounds. And they'll hook them up to this trapeze-like device and let them practice moving around in a low gravity environment as they would on the moon as well as on Mars. To the right of that is a vehicle that's being evaluated for moving around on the surface of Mars or the moon. Unlike the old lunar rover, if you've seen those photographs of them, moving around up there on the moon, the lunar rover was like a Jeep without any doors on it. I mean, it threw around a lot of dust. The astronauts had to remain fully suited up. This will be totally closed off, so the astronauts can sit in there and shirt sleeve comfort. However, the suit will be outside, so the astronaut will crawl into an airlock, get into that suit, and then they'll close the airlock, and he'll be able to venture outside. Now, big reason for that is try to keep as much of the lunar dust out of the living space, because that lunar dust is very abrasive. It looks like tiny shards of glass, so they have to be very careful. They can degrade the fabric on the moon suit, and you certainly don't want to breathe any of that. And if you look at these blue banners along this far wall over here, those are all winners from local or actually national and international robotics winners. So NASA actually sponsors high school robotics competitions here. So some of you, as you get a little older, you may be interested in doing something like that. Okay, ladies and gentlemen, we're going to go ahead and head down the stairs. And if you have any questions, don't hesitate to ask myself, Joe, or our driver, Jacob. And if we can't find the answer for you, we'll radio ahead, and they'll get on the computer and find out whatever you need to know. Once again, friendly reminder, please get back in the same row as you got out of as we reboard the tram. Thank you. That sound all right, y'all?
Sounds great. All right, thank you. Usually it's kind of like R2. He doesn't usually have legs. He just kind of walk down.
You have to be really smart now.
These are all low stability
Yes, right. There's sunglasses. We're in the front seat. That's why she said Big friend.
We'll do a part 2.